Hello out there in YouTube land and welcome to the whitchermath channel. Again, thanks for coming back. Hey, I wonder, in a world without pi, can I estimate the area of a circle pretty accurately? Is there a way to do it if I completely forgot what pi is or didn't even know about it? Can I do this? Let's take... First, we got to get the tomato paste out of the way. And then this post-it note, which you can already see through. Spoiler alert. And the answer is yes. I'm going to use this shiny quarter as an example of what got me thinking about this. So I'm looking at this quarter, and I've been running across a lot of students that are finding the area of a circle get in the way of doing some other simple estimating calculations, and it always comes back to pi and getting things confused with circumference. And anyway, as I look at this example here, that was way off camera. I hope you didn't hear that. I noticed, hey, there's a square here. I wonder if there's a relationship between a square and a circle having the same diameter. Maybe there's a key there. Just like pi is the relationship between the diameter and the circumference, direct relationship, right? Because if I have the diameter, pi is my relationship there. What I was wondering, if I had a square, is there a certain relationship to a circle having the same diameter? That's just a question I had yesterday. I'm so old, and it took me all my life to finally have this question. And a lot of you that are smarter than me out there probably already know the answer. But this is pretty fun to discover something, or feel like I discovered something. Okay, so let's find out. We're going to test the theory by taking something super simple and make this little square. Sorry, it's early. My throat is not its usual self right now. I'm going to take a square with a side length of 2. And down here, switch to red, I'm going to take a circle with a diameter of 2. And I'm going to work everything out in the traditional way and compare the answers. And then I'm going to do it with a slightly larger shape and see if I get the same relationship. And if I do a few times, and this is a repeatable pattern, then I'm going to be pretty darn excited. So the area of this square is simply 2 by 2, 2 squared, 2, comma, squared. You can watch some of my other videos to get these fabulous connections between language and math operations. Since it's a square, that's why we call this little symbol a square, because it finds the area of a square. Anyway, the bottom line is that's 4. Okay, now we're going to go to the circle, which traditionally we would go pi times r squared. So let's do that. We're going to use some background information that we have. And what is r in this case? 1, right? The radius is 1. The diameter is all the way across. So if I square that, I get 1. And if I multiply that by pi, well, technically I get pi. But let's quantify this. Most people use a common approximation of pi as 3.14. That happens on standardized tests and whatnot. If you're approximating and having a multiple choice answer, then that's going to be your choice there. Let's look at our two answers here. We got the square is 4, and a circle with the same diameter is 3.14, approximately. Keep in mind, all of these are estimations. Estimations are a fabulous way of getting to the root of a problem. Little math joke there, right? The root of a problem. Okay, it's too early for that, right? And so we're estimating. I see kind of a relationship here because 3 is 75% of 4. So I'm thinking something like that. Now let's go to another one. Let's go one notch bigger. 2, 3, 4. Let's do the square with sides of 4. The area is now 16. Wouldn't it be amazing if we had a similar relationship here? So I'm going to make a circle with a diameter of 4 using all my artistic abilities. Oh, you got to pretend it's a circle. Pretend. Okay. R squared times pi. Traditional way of doing this. 3.14, since we're approximating, times 2 squared, right? Because the radius is 2, diameter is 4. So I end up with pi times 4, which is about 12, a little more than 12 and a half. Let's observe. We need to observe and decide if we're going to have some kind of relationship here, or if we just need to move on and meet some other math relationship. It looks kind of similar to me. Look, 3/4, 12/16 is about 3/4. It seems like there's a linear or a proportional relationship here. Let's do just one more example, and then we'll conclude this video. I went 2. I went 4. What should I do next? Okay, I'll do 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this is called a 6 square because it's a square made out of 6s, which is why we actually write the number 6 and the symbol for a square, which is the little 2. You already knew that. 6 times 6, 36 is the area. Let's make a circle. Circle? Peter Brady. See if I can do a better job this time. Help, art students. How do you draw a freehand circle? I don't know. But it doesn't matter to me right now. No offense. Okay, so radius is 3 here because the diameter is 6. Going to keep using the same algorithm, same thing we've used on the other ones. Pi r squared. The side benefit of watching this video is it may be a moot point, my original question, because you're getting repetitions on actually doing the pi algorithm. But then we're going to pretend like pi doesn't exist after that. 3 squared, 3 times 3. Very good. 6. Upside down. Okay. And that's going to be, based on past experience I have, about 28.26, right? 27. 3 times 3 is 9. Okay. That's not so clear to me because if I was going for the 3/4 relationship, and then I see the 12 out of 16, and I see the 28 out of 36, it's not so obvious. So let's test it out. I'm going to take 3.14, divide it by 4, see what my ratio is, my multiplier. On this one, I'm going to take 12.56 divided by 16. I just wondered something. Now I tested it out 3 times. It kind of seems like it works, but let's verify. Okay, these are all based on approximations. Very important to note that. Don't cite me as a source on saying these are exact answers. So I get 785 thousandths there. Let's do this second one. And I get the same thing, and I'm starting to get kind of excited here. I don't know about you, but I'm totally excited about this. I sure hope this is the same answer. The same value. Yes! Okay, so we've arrived at my theory here is if I have a square with diameter d, and I find the area and multiply that area by 785 thousandths, I get the area of a circle with same diameter. Woo! Let's test that out. Quick test. First, we'll test it in a world without pi. With no pi. What a sad world that would be. Okay, and let's do something crazy that we don't know the answer for. Let's say that I have a square here with the sevens. Let's go 7.5. Let's get crazy. So 7.5 squared. Come here, Mr. Calculator. 7.5 squared is 56.25 square units, of course. Okay, now for the fun part. Circle, diameter, means radius is half of that. Oh wait, I don't need radius anymore, do I? If I just test my theory out and go times 0.785, let's see what I get. About 44, like that. That's using my new method, Mr. W's method. I'm sure this is out there, but I'm pretending like I just made an amazing discovery. Let's compare. We're going to compare to the world with pi. So we're going to go r squared times pi. Okay. Ultimately, we want to compare our theory to the reality, and then if we can trust it, we can use it. Is the silence awkward to you? Not me. I kind of like silence. Okay, I wrote way too many decimal places there. That seems pretty good. In fact, let's test this out. Let's take 44. Let's take that whole answer and divide it by... There we go. It works. So let's conclude. Let's come to a conclusion here. Conclusion, if I have given circle and square with same diameter, area of the square times a factor of 7/85 hundredths is going to get me very close to the area of the circle. Woohoo! We did it! We did it! Okay, bye.